we can write the value of a as a equals to minus omega square y, because if you just go through our previous equation, you will get the value of y as a sine within bracket omega t minus kx plus minus phi. So we are just replacing all this term by y. Okay, so our last and the final equation is this one, a equals to minus omega square y. Okay, I hope you know how to do the differentiation. Okay, this is basic, this is fully maths part. Okay, so just term this equation as equation number 3. Okay, we have learned how what is the velocity, what is the respective displacement, as well as by differentiating we have obtained the value of a, or the acceleration, in a progressive wave. Okay. So students, from this particular equation, that means the equation of the acceleration, it is understood that the displacement of the particle y, that means the many equations of the displacement we have obtained, we have seen in the previous pages, in the previous classes, so that the displacement of the particle y and its acceleration a are in the opposite phase. Why in the opposite phase? Because see, it is coming as negative. Okay, so we have seen that from this particular equation, that the displacement y as well as the acceleration a are in both opposite phases. That means the phase differences between them is 180 degree. So if they are in opposite phase, the phase difference will be minus 180 degree. Okay. So the phase velocity, the phase of the velocity of the particle is 90 degree. Okay. This we have seen in the previous cases. Okay. The phase of the velocity of the particle is 180 degree and the phase differences between them, since they are in the opposite phase, the phase differences between them is 180 degree. Okay. I am just writing it as phase difference 180 degree, and the phase of the velocity of the particle, phase of the velocity is 90 degree. Okay, so don't get mixed up. Okay, this we have also seen, and this phase difference we just got from this equation. Okay, so the phase differences between the velocity as well as the displacement or acceleration, whatever you will consider, is 90 degree. Okay, so the maximum acceleration of the particle is plus minus omega square a. That means this we are assuming. Okay, that means the maximum acceleration of the particle is plus minus omega square a, which is equal to plus minus a naught. This we are assuming. Okay, so I am writing it as a max equals to plus minus omega square a. Okay, why we are writing it as plus minus a? Suppose if your acceleration is negative, then this term will be your positive, isn't it? That means we are writing it as a max will be equal to plus minus omega square a, and we are terming it to be as plus minus a naught. Just we are using this term a naught here. Okay. Since we have seen that the a max, or the maximum value of the acceleration of the particle, will be plus minus omega square a, so this omega square a, or the term a naught, this term is called as the amplitude of acceleration of the particle in a progressive wave. So amplitude, always we use the term big A for amplitude, but this is the case of the amplitude of the acceleration. Whatever amplitude of the acceleration of the particle will be, we are terming it as a naught. Okay. So I think all these equations are clear to you, especially this phase difference and the phase of the velocity of the particle. You just note it carefully. this is phase difference is 180 degree and a phase of the velocity will be 90 degree. I've explained it in the previous videos, they can also go through. Okay, so now students, we will learn the relation between the particle velocity and the wave velocity in a progressive wave. Okay, in the class students, when we were discussing at the beginning, before starting these equations of the progressive wave, we have learned that what is the meaning of the term particle velocity as well as the wave velocity. Just a basic part we have learned. So now we will see that what relationship we can able to draw between the particle velocity and the wave velocity in a progressive wave, that we will learn in this class. Okay. Okay. So as usually, let us assume the displacement of the particle in a progressive wave be y equals to a sine within bracket omega t minus kx plus minus phi. Okay, let us assume